All right, these are the video notes for multiplying and dividing integers. So we are going to start off by modeling multiplication on a number line. So first thing I want to do is remind you what 7 times 8 means. So one of the meanings of 7 times 8 means that there are 7 groups of 8. And that's how you learned it when you first learned multiplication. When you learned multiplication, they would tell you there's 7 groups of 8. How many is there altogether? Okay, so we're going to use that idea here when we model on a number line. So I'm going to put my star at 0, just like before. And this says 5 times negative 2. It's saying I have 5 groups of negative 2. Okay, so here's 1 group of negative 2, 2 groups of negative 2, 3 groups of negative 2, 4 groups of negative 2, 5 groups of negative 2. So 5 times negative 2 must give me a negative 10. There's my 1, 2, 3, 4, 5 groups, and each time I moved 2 places to the left. We can try that again. 3 times negative 1, 3 groups of negative 1. So I'm going to put a star on 0. I have 3 groups of negative 1. So here's 1 group, 2 group, 3 groups. Each time I just move to the left 1 spot. So 1 group, 2 group, 3 groups. What do I land on? I land on negative 3. So I know 3 times negative 1 is negative 3. Okay, so that makes sense when I have a whole number times a negative number. When I have a positive times a negative. What if I have a negative times a positive? Well, there we have to remember that multiplication is commutative, which means we can write it in any order. Okay, so that means we can write it in any order. Negative 4 times 2 is the exact same thing as 2 times negative 4. So I just reverse the order, so I can do this again. This is saying 2 groups of negative 4. So here I am starting at 0. Here's 1 group of negative 4. Here's 2 groups of negative 4. I land on negative 8. I know negative 4 times 2, or 2 times negative 4, gives me the answer negative 8. But what about if it's a negative times a negative? Now I can't rewrite it. I can't have negative 3 groups of negative 3. It doesn't work. You can't make negative 3 groups. So remember last week we talked about how the negative sign had 3 different meanings. It can mean subtraction, it can mean negative, but it can also mean the opposite of. This is where we kind of use that opposite of a little bit. So I could rewrite it to look like this. And what this is saying is the opposite of 3 times negative 3. Remember, numbers right next to each other in parentheses means to multiply. So this is saying the opposite of 3 times negative 3. All right, so let's try that. If I start at 0, that's saying 3 groups of negative 3. So here's 1 group of negative 3. There's 2 groups of negative 3. Here's 3 groups of negative 3, and I land on negative 9. But now it's saying the opposite of that. And the opposite of negative 9 goes all the way over here. The opposite of negative 9 is positive 9. So I can see by my number line that negative 3 times negative 3 would give me positive 9 as an answer. And I just proved why. I think of it again as the opposite of 3 times negative 3. So that leads us to a rule for multiplying integers. If the signs are the same, so if I am multiplying 2 negative numbers or 2 positive numbers, my answer will always be positive. Okay? And if I'm multiplying signs that are different, the answer is always going to be a negative. And this is where it gets a little murky with the addition rules. But because before I said a negative plus a negative was a negative, now a negative times a negative is a positive. And this is where kids start to get really confused because the rules are similar, but there is that one little difference between multiplying and adding. So let's try some examples. Okay, if it were me, I would do the solving first, ignore the sign, and then figure out what the sign would be. So 6 times 5 I know is 30. My signs are the same. They're both negative. Okay, signs are the same. My answer is positive. All right, so my answer is positive 30. This says 9 times negative 4. Again, remember, a number right next to parentheses means to multiply. So I would say 9 times 4 is 36. My signs are different in this case, so my answer is going to be negative. 9 times negative 4 is negative 36. Negative 10 times negative 3. My signs are 10 times 3 is 30. My signs are the same. Signs are the same. My answer is positive. So my answer is positive 30. 8 times 12. We probably don't even need to think of our rule for this one because we know a positive times a positive is a positive. We learned that a long time ago when we first started learning multiplication. So really all I have to do here is the 12 times 8. And if you can do it in your head, that's great. If you're someone that needs to do it on the side of your paper, you do it on the side of your paper. Okay? And you come up with 96. And again, we already knew a positive and a positive made a positive. Okay, here, 15 times negative 7. Okay, so I need to do 15 times 7. Well, that's not one I know off the top of my head, so I'm going to write it down over here. Or I could count by 15s and maybe I could figure it out. So 7 times 5 is 35. 7 times 1 is 7, plus 3 is 10. So I know it's 105. My signs are different. Difference negative. My answer is negative 105. Okay, negative 18 times 4. Again, we forget about the signs for a second and we just do 18 times 4. All right, so I'm not sure what that is. I'm going to do it over here. 18 times 4. 8 times 4 is 32. 4 times 1 plus 3 is 7. So I know it's 72. And my signs are different, and different is negative. So my answer is negative 72. Okay. Now, as for the modeling of this, you will not have to ever do this on a quiz or a test. I just wanted you to see how we're coming up with these rules of positive and negative. So let's flip it over to the back. Something that goes along with multiplication is when we have numbers raised to a positive power, and we'll only deal with positive powers this year. So it says when a negative number is raised to a power, meaning a negative number is in the base, if the power or the exponent is even, your answer will be positive. If the power is odd, your answer will be negative. Okay, so for instance, negative 2 to the 5th power. Okay, that means this. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Negative 2 5 times. All right, so using my rule, it says if my power is odd, 5 is an odd number, my power is odd, my exponent is odd, so I know my answer is going to be negative. Okay, and then 2 to the 5th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I should get the answer negative 32. I'm going to prove it to you over here. So if I did a negative 2 times a negative 2, I would get a positive 4. If I took that positive 4 and multiplied it by that negative 2, I would get negative 8. If I took that negative 8 and multiplied it by negative 2, I would get a positive 16. If I took that positive 16 and multiplied it by a negative 2, I would get negative 32. It just goes back and forth between negative and positive. So let's try another one. Negative 7 to the 3rd power. So I'm going to figure out what 7 to the 3rd power is first. So 7 times 7 times 7. 7 times 7 is 49. 49 times 7. Ooh, that's a tricky one. Let's try that over here. 49 times 7. 9 times 7 is 63. 7 times 4 is 28. And 28 plus 6 is 34. So I come up with 343. And then I look at my exponent, 3. 3 is an odd number. Odd, your answer is negative. So my answer would be negative 343. Negative 4 to the fourth power. So I'm going to do 4 to the fourth power. I'm thinking 4 times 4 times 4 times 4. Okay, so I have 4 times 4 is 16. 16 times 4 is 64. And then I have 64 times another 4. So times another 4. That I don't know, so let's come over here. 64 times 4. 4 times 4 is 16. 4 times 6 is 24, plus 1 is 25, so 256. My exponent is a 4. That's an even number, so my answer is going to be positive 256. All right, try the next one. Negative 1 to the 15th power. Okay, that's like negative 1, negative 1, negative 1, negative 1 times negative 1 times negative 1, and so on, 15 times. Okay, well, 1 times itself is not 15. That's where people make a mistake. 1 times 1 times 1 times 1 times 1, 15 times is still going to be 1, because any number, or 1 times 1 is 1, times 1 is 1, times 1 is 1. So I'm going to write down 1, and then I'm going to look at my exponent. 15 is odd. Odd means negative. So my answer there would be negative 1. Negative 3 to the fourth power. Okay, so that's really 3 times 3 times 3 times 3. That's what I'm going to focus on, and then I'll worry about the sign. So 3 times 3 is 9. Another way you could do it is like this. Look at this, 3 times 3, it's also 9. And then 9 times 9 is 81. That's another way you could solve exponents. Now I look at my power. My power is 4, or my exponent is 4. 4 is an even number, and even means positive, so my answer is a positive 81. Okay, I want you to fix something on this for me. This should be a 2, not a 3, and it does make a difference because I want to prove a point to you. If you notice on all of the other problems, there is a set of parentheses around it. And on this one, there's not a set of parentheses. So those parentheses are extremely important. Those parentheses for here, it's saying negative 2 to the fifth power. This is saying negative 7 to the third power. Negative 3 to the fourth power. This is not saying that. Since there's not parentheses around the negative 5, this is actually saying 5 to the second power and take the opposite of it. So 5 squared is 25. The opposite of 25 is negative 25. Now, if I would have followed my rules with the parentheses, then I would have said 5 times 5 is 25. And because it's even tells me my answer is positive, so I would have got it wrong. So that you gotta be really careful of that. Now, we're not gonna trick you this year. We're always gonna use ones with parentheses, but we just wanted you to be aware that those parentheses are in fact extremely important when you're working with exponents. Now we're gonna do a little bit with division. So it says dividing integer rule. Okay, the rules for dividing are exactly the same as multiplying, which makes it really nice. So if the signs are the same, my answer is positive. If the signs are different, my answer is negative. And we don't need to worry about modeling this at 1 at all. So again, for dividing integers, we divide the numbers like they have no sign, and then we look. If they're the same, my answer is positive. If they're different, my answer is negative. So I would say 48 divided by 6. I know that's 8. My signs are the same. Same means positive, so my answer is positive 8. Here, 25 divided by 5, I know is 5. My signs are different. Different says it's negative, so my answer is negative 5. Negative 99 divided by 9. Okay, 99 divided by 9 is 11. My signs are different. Different means negative. You could even say different means difference, and difference has a subtraction sign, so you could think of that as a negative too. Okay, negative 121 divided by negative 11. 121 divided by 11 is 11. A negative divided by negative. Those are same signs, which means my answer is positive. Okay. Negative 112 divided by 8. Ooh, I don't know if I know 112 divided by 8 off the top of my head. So again, if I have to show my work, I will. 8 does not go into 1, but it does go into 11 one time. And make sure you line things up very carefully. I have a remainder of 3, which is smaller than 8, so I can go ahead and bring down the 2. 18 goes into 32 4 times. 4 times 8 is 32, and I have no remainder. Okay, so I know my answer is 14. Now I have signs that are different. Different means difference, which means it's a negative. And finally, I have 72 divided by 4. Okay, 72 divided by 4 is 18. Okay. And then my signs are different, and different means that the answer will be negative, so negative 18. So now what I want you to do is, this is a mixed review. It's got adding, subtracting, multiplying, dividing. It has a couple exponential problems in there too. I want you to pause the video right now, and I want you to try those 12 mixed review problems. Once you've answered all 12, then continue the video and see how you did on them. So pause. All right, now you've answered your questions. Let's see how you did. So this one's addition. Addition is good. I don't have to change anything. I just use my addition rules. When my signs are the same, I add them and keep their sign. So 8 plus 12 is 20, and I keep their negative. My answer is negative 20. Okay, here, division. Division, I just do the math as normal and then decide on the sign. So 14 divided by 2 is 7. My signs are the same, and same means positive. You could think of it as same means sum, and sum is an addition sign, so it's positive. Okay, 8 times negative 9. So I do 8 times 9, you get 72. And then I have a negative, and a positive. My signs are different. Different means different, so I need to have that negative sign in there. Negative 6 to the third power. Ooh, this might be one I need to write out. So I know it's 6 times 6 times 6. So let's see. 6 times 6 is 36 times another 6. 36 times 6. 6 times 6 is 36. Write down the 6, carry the 3. 6 times 3 is 18 plus 3, 19, 20, 21. So I know it's 216. And now I got to decide on a sign. I have an odd exponent. My exponents are odd. Remember up here, my answer will be negative. So I should have negative 216. Okay, this one says 12 times negative 7. So 12 times 7 is 84. My signs are different, so my answer is negative. Different, difference, must have my negative sign. 44 divided by 4. Well, 44 divided by 4 is 11. I have a negative divided by a positive. My signs are different. Different means different, so I must have to have my negative sign in there. Here's a subtraction problem. Now remember, with subtraction, we have to change it to addition. We have to do that LCO, leave, change, opposite. So I'm going to leave the 9, change to addition. My negative 17 becomes a positive 17. So really, I'm just doing 9 plus 17, and that would give me 26. All right, here's division. So I'm going to do 64 divided by 2, and I get 32. My signs are the same, and same means sum, which is a positive sign, so my answer is positive 32. 15 plus negative 23. Okay, it's already addition, which is good, so I use my addition rules. My signs are different. Different means I have to take the difference. 23 minus 15 is 8, and I take the sign of the larger number. 23 is bigger, and it's negative, so negative 8 would be my answer. All right, one more row. 10 times 3 is 30. Signs are the same. Same means sum, which means sum is positive. Negative 3 squared. All right, so 3 squared just means 3 times 3, which I know is 9. I have an even exponent, and even exponents are positive, so my answer is positive 9. And finally, I have subtraction here, so I know I need to do leave, change, opposite. My signs are different, or sorry, my signs are the same. So I'm going to add the numbers and keep their sign. So my answer is negative 24. So now that you've done this notes page, I need you to do the practice that's also in the file folder for today. So look at these notes, make sure they're completed, and then there's a 7-question practice in the file folder today. If you get a 70% or higher on that practice, I will give you the completion point for getting it done. If you get below a 70%, you can do it as many times as needed to get you to that 70%, so I can give you the point, just like a Khan Academy assignment. That's it. If you have questions, next time I see you in class, make sure to ask them.